So just I'm recapping the topics that I have taught you in the previous class. So here C is the center of curvature of the spherical. So simple definition of center of curvature is that the center of curvature of a spherical mirror is defined as the center of a sphere of which a spherical mirror itself is a part. Next one is that center of surface of mirror. You see, this is the center of a sphere of which mirror itself is a part. Now your mirror is only from A to B via P. So center of this mirror, midpoint of this mirror reflecting surface is P, and this is called pole or vertex. So pole of the mirror is a point on the reflecting surface which divides the reflecting surface in two equal halves. This is called pole. So you see here, if you take this point, you will see that portion of AP is just equal to BP. So this point P divides this spherical mirror into two equal parts. So this point is called pole or vertex of the mirror. Next, focal length. Focal length is basically distance. And first of all, we have to define focal point and then focal length. We have discussed center of curvature, vertex of mirror, and now aperture. Aperture is basically diameter of the spherical or reflecting surface. You see here, this is the reflecting surface. So the diameter of this one from this end to this end is called aperture. If aperture increases, this implies that size of a spherical mirror increases. So maximum size of a spherical mirror can be equal to diameter of the sphere of which mirror itself is a part. Focal point of the mirror. Focal point of the mirror. Okay. Now focal point of the mirror. In the last class we have already discussed, it is defined as a point on the radius of curvature of the mirror where a parallel rays parallel to radius of curvature or principal axis appears to be converged or diverged is called focal point. So you see here this F is focal point and here this F is focal point because any ray parallel to this principal axis. So before going into that, principal axis is defined as the virtual line joining the vertex of the mirror and center of curvature of the mirror and beyond. And focal length is defined as the distance between the pole and focal point of the mirror. It's called focal length. It is denoted by a small f. Now come to the point, focal point. What do you mean by focal point? A point on the principal axis where rays parallel and close to the principal axis passes after reflection is called focal point. Once again, remember what do you mean by focal point or focus? Simply focus or focal point is the same thing. So point on the principal axis, point on the principal axis where a rays parallel and close to the principal axis pass after reflection from the mirror. You see here, this is the principal axis. Principal axis is a virtual line joining center of curvature and vertex of the mirror. So you see here, this is the virtual line and joining the pole and center of curvature and extended beyond that. You must remember. So a parallel rays which is parallel to principal axis incident on the mirror, then after reflection it will pass through a single point on this principal axis. This point is called focal point and is denoted by F. In this case, this is a concave mirror because it is silvered from this side, so its reflecting surface is this side, facing towards center of curvature. So, and viewer is this side. In concave mirror, viewer is this side. On the other hand, in convex mirror, viewer will be outside. So, you have got it, a focal point. Now, again we define focal point using convex mirror. You see here, convex mirror is silvered from inside, from this side. Here image is made wrongly because this dark blue line must be this side, indicating that silvered line. Okay, so this side is reflecting surface. So point on the principal axis where rays parallel to principal axis appear to be diverged from after reflection is called focal point of the convex mirror. You see here a parallel rays parallel to the principal axis diverge, reflect back to this sides because it cannot cross the reflecting surface. So we extend virtually this rays, reflected ray, then this reflected ray appears to be converted at this focus. So observer at this side will see that ray is not coming from this side, but for observer it will appear to be coming from this point. So this point will act as a source of light virtually. Observer will see, and observer will be this side. So this is the focus and this is the center of curvature of convex mirror. Now, relation between focal length F and radius of curvature R. In your book, radius of curvature is denoted by capital R. So even I can edit it by capital R. So for convenient, you must understand that in your textbook, radius of curvature is denoted by capital R and focal length is already denoted by small f. So now we are going to deal with the relation between focal length f and radius of curvature of.
नमस्ते सर.
हेलो, हाँ जी बोलो.
नमस्ते सर.
Namaste. This relation, you see, this is the spherical mirror. Red one is, and this dotted line indicates that this is a complete sphere of which this spherical mirror itself is a part. And this P is the vertex of the spherical mirror or pole of the spherical. Now a single ray, incident ray, parallel to the principal axis. You see, this is the principal axis. This dotted line is the principal axis. So a single incident ray parallel to principal axis incident on this spherical mirror. Then after reflection, this ray must pass through a point on the principal axis called focus. So this is the focus. So this ray passes. You know that angle of incidence is nothing but what angle made by the incident ray with the normal. So this yellow line is the normal because a line drawn from the center of a sphere to the surface of a sphere is always perpendicular because the radius of a sphere is perpendicular to the surface of a sphere. So this yellow line acts as a normal. Therefore, angle made by the incident ray AM with the normal CM is theta, And similarly, angle made by the reflected ray Fm with the normal Cm is also theta, because you know well that angle of incidence is just equal to angle of reflection according to law of reflection. So this is theta, this is theta. Now, as this line is parallel to this line, virtual line, therefore this Cm act as a transversal. Therefore, alternate angle will be equal. So this is the theta and this is also theta, alternate angle. Okay. Now we have to consider the triangle FCM. FCM, which is an isosceles triangle. Therefore, because if two angles are equal in a triangle, then triangle will be isosceles triangle. So therefore, two sides, corresponding sides will be equal. That is FC equal to FM. It is well clear. Now consider a ray AM is paraxial. Paraxial means it is very closer to the principal axis. Then if this AM is very closer to principal axis, then M will be closer to P. M will be closer to P. In that case, Fm must be equal to Fp. If you bring M very closer and closer to P, then Fm must be equal to Fp. Therefore, here paraxial rays is described because parallel rays or incident ray very closer to the principal axis is called paraxial ray. So Fm equal to Pf. Therefore, Cm equal to Cp. Cm equal to Cp because it is radius. Cm is radius and Cp is also radius. So this is equal. Now Cp must be equal to Cf plus Pf. Cf plus Pf. Therefore, as we know that Cf is just equal to Fm, Fc equal to just equal to Fm, and Fm is just equal to Pf. So Pf plus Pf equal to 2Pf, and 2Pf equal to Cp, and therefore Pf equal to half Cp. Pf is nothing but focal length, because you know that distance between focal point and pole of the mirror is called focal length and is denoted by small f. And Cp is what? Distance between center of curvature and pole of the mirror is called radius of curvature. So Cp equal to r. You can write here capital R. And hence focal length is just equal to half of radius of curvature. This is the relation. This is the relation. Now, next thing we have to discuss here. Next topic. This is the relation. Radius of curvature of a spherical mirror is just equal to twice of focal length of the spherical mirror, or is focal length of the spherical mirror is just half of the radius of curvature of the spherical mirror. Next one is we have to state the rules that is used to draw the image diagram for the spherical mirror. So images formed by a spherical mirror, we have to learn a specific rules. Here a spatial ray diagram we have to learn about, and only there are three spatial rays that we have to learn. So information about the image in any case can be obtained either by drawing a ray diagram or by calculation using formula. So two concepts is there. First one is drawing the ray diagram. Second one calculation, mathematically calculation. So by drawing ray diagram, one can locate the formation of image or location of image. For that one, we have to learn or remember about the spatial ray. There are three spatial rays that we have to remember again and again. First one is that any incident ray which is parallel to principal axis of the spherical mirror is reflected through the focus after reflection. Any incident ray which is parallel to principal axis will pass through focal point or focus after reflection. So you see here, this arrow is an object, and from tip of object, an incident ray parallel to principal axis is incident on the mirror like this. Then after reflection, it must pass through a point on the principal axis called focus. It must pass through focus like this. So you must remember that any incident ray which is parallel to principal axis must pass through focus of the mirror after reflection. This is the first spatial ray. Now we have to remember the second spatial ray. Second spatial ray is the reverse of the first one. In this case, any incident ray which is passing through the focus, becomes parallel after reflection through the mirror. So this is reverse of that case. Any incident ray which is passing through the principal focus or focal point is reflected back parallel to the principal axis. You see here, this ray is not parallel to the principal axis, but it directly passes through the principal focus like this. Then after reflection, it must become parallel. In the previous case, in first case, the incident ray was parallel to the principal axis. Here, the reflected ray is parallel to principal axis. In the first case, incident ray was parallel to principal axis, then reflected ray passes through the focus. Here, incident ray passes through the focus. Therefore, reflected ray will not pass through the focus, and hence it is parallel. This is second spatial ray. Now we have to learn about third spatial ray. Only these three spatial ray will help you to draw a ray diagram for various position of object in front of a spherical. Third spatial ray is defined as a ray passing through center of curvature is reflected back through the center of curvature. Hello? Okay. Is reflected back through the center of curvature. So, you see here, this is the third spatial ray, a ray passing through the center of curvature. This is directly passing through the center of curvature. So after reflection, it will reflect back through the center of curvature, because a ray passing through center of curvature is perpendicular to the spherical mirror, and hence it reflects back to the center of curvature. Only these three rays that we have to use in order to draw ray diagram. Okay. So now we have learned three spatial ray, and now we are using these three spatial ray. Out of these three spatial ray, only two can be required to draw the location of image for given position of object. With the help of compass, we can draw a spherical mirror. So let us check how to draw using compass. Place the pointer of compass this point at the center of curvature of the mirror, and then move this compass, rotate, and take this point between the compass, distance between the compass and the pointer pencil is called radius of curvature, and then move it, then you will draw mirror. You see here, this is the spherical mirror and concave mirror. Place here compass and pencil here, and then rotate it like this. And this is diverging ray heading towards the eye. Diverging rays heading towards the eye. You see here, object is placed at this place, that is between focus and center of curvature. So first spatial ray is used. First spatial ray must be parallel to principal axis. So this ray is parallel to principal axis. Okay. Here, parallel to principal axis. Then after reflection, it must pass through the focus. So this is the first ray. Now we have to use second ray. Second ray must pass through the focus. Incident ray must pass through the focus. Then after reflection, it becomes parallel. So you see here, second ray is drawn passing through the focus. Then after reflection, it becomes parallel. Now we have to use third ray. And in third ray must passes through the center of curvature. So you see here, a ray passes through center of curvature and will return back and will pass through center of curvature and this. And here is observer. So all the three spatial ray has been used in order to draw the diagram for the image formation, for the position of object. Now, see here, image formed by concave mirrors. Object is placed here beyond the center of curvature, away from the center of curvature. Object is here. So, now, in order to draw ray diagram, first of all, what we have to do? We have to draw first spatial ray. That is, a ray passing from the tips of the object and is parallel to the principal axis. Then after reflection, this ray must passes through principal focus like this. So this is the first spatial ray. Now we have to draw second spatial ray. Second spatial ray must passes through the principal focus. You see here, starting from this object and then passes through this focus and then to mirror, and after reflection it becomes parallel. Okay. Now only this is enough because incident ray and reflected ray intersect at this point. Therefore, image will be formed. But even you can draw third spatial ray. Third spatial ray can be drawn passing through the center of curvature. So this is the third spatial ray. Although it is not necessary to use all the three spatial ray, but in order to show you that here we systematically draw the three spatial ray in order to show the image formation by the concave mirror or spherical mirror. So first we draw first spatial ray, then second spatial ray, and then third spatial ray if you need. Although here it is not necessary, but still we draw third spatial ray passing through center of curvature, and after reflection it becomes it retraces its path and again passes through the center of curvature. So image formed is here. It is of a smaller size and inverted and real image because all the rays intersect here really. Real intersection taking place here. That's why real image is formed. So you see here object is of bigger size and erect, but image is inverted and of smaller size. So when object is placed beyond the center of curvature, here you see here is the center of curvature and object is here beyond the center of curvature or at infinity. So between and then image form will be at a point between center of curvature and focal point. Nature of image will be real, inverted, and smaller in size in comparison to that of the object. So actual diagram of this case is here you see. Actual diagram of this case is here. Now here in this case only two spatial ray has been drawn. One is spatial ray 1 and here spatial ray 3. So only two ray is enough to use for the ray diagram for the image formation by the spherical. Now you see this is the second situation when object is placed at the center of curvature, then where is image formed? So you see here, this is the object. So first ray, spatial ray has been drawn parallel to principal axis, then after reflection it will pass through the focus. Then we have to draw second spatial ray passing through the focus, then after reflection becomes parallel. So you see here the two reflected ray intersect at this point, so indicating that image will be formed at this point. So here you see that image formed is inverted, real, and of the same size as that of the object, and also image formed at the same location where object is there. This was the second case, and now third case we have to use when object is placed between center of curvature and focus, then where is image formed? Let us check out. This is the object. This is the object, and you draw first spatial ray parallel to principal axis, then after reflection it will pass through the focus. Okay. Now we have to draw second spatial ray passing through the focus, then after reflection it will become parallel to the principal axis and intersect at this point, indicating that image will be formed at this place. And you see here that size of image is greater than that of the object, and image is inverted with respect to object. Image is real because real intersection taking place. Real intersection taking place, yes. Hello. Okay, okay. Yes. So third case is when object is placed. This has already been. So here image will be formed beyond. Image will be formed beyond center of curvature, and nature of image will be real. An image will be inverted with respect to object, and size of image will be larger than that of the object. So here image is magnified with respect to object. Now fourth case is there when object is placed between focus and pole of the mirror. Then where is image formed? In this case again, this is the object you see here on the principal axis. Now first spatial ray is drawn parallel to principal axis. Then after reflection it will passes through the focus like this. Here second spatial ray cannot be drawn because second spatial ray is passed through the focus. So here we cannot use second spatial ray. So third spatial ray is used here. Third spatial ray is drawn, and as it is perpendicular to the spherical mirror, so reflected back like this. So we see here these two reflected rays will never intersect each other at any point, because these two reflected rays are diverging away from each other. Therefore, we extend this reflected ray behind the mirror and see where these two rays virtually appear to intersect. So you see here these two rays virtually appears to intersect at this place. So in this case, image will be formed magnified larger than that of the object. Image is erect and image is virtual. So in hello, yes, yes. Is there any problem? Now try to understand. Location of image is behind the mirror. Nature of image is virtual and is upright with respect to object and larger than that of the object. So now fifth case is that when object is placed at infinity or when object is placed at focus.
क्वेश्चन है सर।
हाँ बोलिए।
सर जो कोई भी रे फॉल अगर जब फॉल करेगा मिरर पे तो वो 90 डिग्री परपेंडिकुलर ही रहेगा।
नहीं, कोई नहीं, जो रे प्रिंसिपल एक्स ये सेंटर ऑफ कर्वेचर से पास कर रहा है तो गारंटी है कि वो मिरर पर परपेंडिकुलर ही होगा, और जैसे ही परपेंडिकुलर होगा इट विल रिफ्लेक्ट बैक फॉलोइंग द सेम पाथ। अब समझ में आ गई बात?
हाँ, जो सर थर्ड रे था।
हाँ, थर्ड रे की बात कर रहा हूँ। थर्ड रे हमेशा सेंटर ऑफ कर्वेचर से ही पास करता है। वो स्पेशल रे है, जब कभी आपको जरूरत होगा तो आप थर्ड रे का यूज कर सकते हैं, मन होगा सेकेंड रे का यूज कर सकते हैं, जहां कहीं भी जरूरत होगा। ये एक प्रकार से ये समझ लो कि जैसे इंग्लिश का अल्फाबेट होता है ABCD, उसमें से जब जो अल्फाबेट की जरूरत होता है उसका यूज करके हम वर्ड बना लेते हैं, ठीक उसी तरह से ये आपके रे डायग्राम के लिए अल्फाबेट है। ये 3 स्पेशल रे, जब जहां जरूरत होगा उसका यूज करके हम इमेज बनाते हैं। कभी कई जगह पर तीनों स्पेशल रे का यूज करके हम बना सकते हैं। आप समझ में आ गई बात?
यस सर।
तो स्पेसिफिकेशन आपको याद रखना होगा कि फर्स्ट स्पेशल रे जो होगा प्रिंसिपल एक्सिस के पैरेलल होगा एंड आफ्टर रिफ्लेक्शन विल पास थ्रू द फोकस। सेकेंड स्पेशल रे जो होगा will first pass through the focus, then after reflection it becomes parallel to the principal axis. सेकेंड इंसिडेंट रे कभी भी प्रिंसिपल एक्सिस के पैरेलल नहीं होगा, बल्कि आफ्टर रिफ्लेक्शन बिकम्स पैरेलल। थर्ड स्पेशल रे जो होगा इज नेवर पैरेलल टू प्रिंसिपल एक्सिस but pass through the center of curvature, and after reflection again it will pass through the center of curvature. तो अब ये आपका नोट है, पॉइंट टू बी नोटेड। इफ द ऑब्जेक्ट इज एट इंफिनिटी, अगर ऑब्जेक्ट इंफिनिटी पर है, a real image is formed at focus. Conversely, और इसका जस्ट रिवर्स क्या होगा कि अगर ऑब्जेक्ट खुद फोकस पर ही हो जाए तब इमेज कहां बनेगा? then real image is formed at infinity. तो कुल मिलाकर के आपका 6 केसेस है। 4 केसेस ऑलरेडी डिस्कस कर चुके हैं और 2 केसेस आपको यहाँ आ गया। ऑब्जेक्ट इज एट इंफिनिटी देन इमेज इज फॉर्म्ड एट फोकस, एंड ऑब्जेक्ट इज एट फोकस देन इमेज इज फॉर्म्ड एट इंफिनिटी। यू सी हियर इन दिस केस ऑब्जेक्ट इज at infinity, so ray is coming from infinity and ray coming from infinity is parallel to principal axis. So after reflection it must pass through the focus. यहाँ रे डायग्राम थोड़ा गलत ड्रॉ किया गया है, ठीक है, क्योंकि यहाँ पॉइंट ऑब्जेक्ट के लिए होगा। ये रे कहाँ से पास करना चाहिए? हमेशा ध्यान दीजिए, फोकस से पास करेगा। दिस रे मस्ट पास थ्रू द फोकस। यहाँ गलत ड्रॉ हो गया, तो इसको आप करेक्ट, मिसअंडरस्टैंडिंग नहीं होना चाहिए। ओके, देखते हैं कौन है। ऑलराइट, ओके, अब आप देखिए सेकेंड केस है कि ऑब्जेक्ट इज एट इंफिनिटी देन इमेज फॉर्म्ड एट फोकस, इमेज विल बी रियल इन्वर्टेड, एंड highly diminished. That means very smaller size in comparison to object. इसीलिए दूर में रखे गए ऑब्जेक्ट हमें काफी छोटा दिखता है, जैसे गैलेक्सी, स्टार्स and sun appears to be smaller than its actual size because the object is infinitely far away from us. That's why its image uh, appears to be small. Now, in all the cases, the foot of the object is on the principal axis. अभी तक जितने भी केसेस बताए थे उसमें से ऑब्जेक्ट की फुट को हमेशा प्रिंसिपल एक्सिस पर इरेक्ट करके रखते हैं and its image is also lie on the principal axis. Image formed by the convex mirror. आज के लिए इतना ही रखते हैं, नेक्स्ट डे हम बताएंगे इमेज डायग्राम फॉर्म बाय द कन्वेक्स मिरर. मुझे लगता है कि ओके और ये इसके बाद आपको हम पढ़ाएंगे एप्लीकेशन ऑफ द मिरर. कल का नेक्स्ट क्लास में हम ये रखेंगे convex mirror, image formation by convex mirror and application of mirror, and then we will draw mirror formula, expression for mirror formula like this, and magnification and sign convention, and then few numericals that you have to practice. Yeah, these are the numericals to solve using mirror formula. So now try to understand. I think that for today it will be this is the convex mirror. You see here it is silvered from inside, therefore its reflecting surface is outside, and in this case, in case of convex mirror, wherever you place the object, image will be formed always between pole and focus. So here object is placed at this place. So you have to use first a special ray, that is ray parallel to principal axis. Then after reflection, it must appears to be diverging away from the focus. So here, you see here, this get reflected like this. So you draw, extend behind, then it will converge to the focus. So it will appear to be diverging away from the focus. Now, second special ray is used, that is this incident ray is directed towards the focus itself. So after reflection it becomes parallel to the principal axis. And third special ray is incident ray directed towards the center of curvature, therefore it reflected back. So it means wherever these three rays virtually appears to be intersecting, this is the location of the image. So this is the image form. So in case of convex mirror, you see that object is larger size, object is of larger size, though still their image is of very smaller size, but size of image is smaller and erect with respect to object. It is not inverted. So convex mirror always forms erect image and of a smaller size. So give larger field of view. Here you see a ray parallel to axis is reflected as though it came from the focal point. Second, a ray heading towards the focal point is reflected parallel to the principal axis, and a ray heading towards the center of curvature reflected back away from the center of curvature. So these are the ray diagram for the image formation by the convex mirror. Now here real situation of convex mirror is, you see here, this is the convex mirror, and you place here a candle as an object, and you will see that image of this candle is smaller in comparison to this. Okay. Now, for today, this is all about application of convex mirror will be discussed in next class. Here the image formed is always virtual by convex mirror. An image is upright and size of image is always smaller in comparison to object. That's all for today.